All right, so this one says Vint is testing ceiling fans in a factory. For one of the tests, he switches the fan on, and after it attains a maximum speed of 500 rotations per minute, he switches the fan back off, recording the amount of time it takes for the fan to completely stop spinning. The given equation models Vint's test, where x represents the time in seconds and y represents the total rotations, the speed and rotations per minute. In other words, if it's going faster, it'll probably take longer to slow down. All right. So he's got a model here of y equals -5 times x squared plus 100x, and then he graphs that. So what he's doing is he's turning the fan on. So let's look at the graph first. So he's turning the fan on. So when he turns the fan on, it's not rotating at all, and there's 0 seconds. So let's label this so we know what's going on. The y-axis is the rotations per minute. The x-axis is time in seconds. So now the line of symmetry, so it's got to ramp up the speed. This is the vertex. Well, what is the value of that? Well, this is also the line of symmetry, right? And that line of symmetry is right between 8 and 12. What number do you think is between 8 and 12? Right in the middle of those. If you're counting by twos, what's the next number? So x equals 10 is my line of symmetry. And the maximum speed which is measured in RPMs, rotations per minute, it looks to be about 500. So what's going on is the fan, as time goes on, the fan speeds up, and then gets to 500. As soon as it gets to 500, he cuts the power. Then the fan slows down, and it looks like it stops here. In other words, this point right here, which is really the time in seconds. So after 20 seconds, the speed of the fan is 0 RPMs. Okay? So then the question is, how long does it take? 20 seconds. Okay? Let's go ahead and collect the calculators. Does somebody want to collect those calculators and hand them to me?